Welcome back to the Bethany Branch Line Model Railroad in N-Scale, currently under construction. Let there be light! This custom light grid culminates 9 months of work. The grid supports 4 rows of LEDs, or light-emitting diodes. This switch panel controls the light strips. The backlights are aimed at the wall to provide even illumination of a future scenic backdrop. The middle lights flood the center of the train board with soft and even white light. The front LEDs target the front edge to make sure every model is in the light. The 3 rows of white lights cover the entire train board from back to front. A row of blue LEDs will be used to create a simulated nighttime look. The Bethany Branch Line's parade level is currently under construction. The scenic level will be added later. When the scenic level goes in, LEDs will be added to light up the parade level below. This video explains how I designed and constructed my light grid. See the video description below for helpful resources, including downloads of the script and parts list, and links to previous videos on this channel. The chapters in this video timeline are Design, LEDs, Frame, Installation, Power, Control, Wiring, Epoxy, Hookup, and Summary. To design the light grid for the Bethany Branch Line, I must answer several questions. What type of lights? How to mount them? How to avoid shadows? How to light for nighttime? How to make the grid lightweight? And finally, how to make it affordable? For answers, I turned to 2 fellow YouTube model railroaders. I'm greatly indebted to both. Marklinofsweden posted a comprehensive discussion of layout lighting options, including types of lights, color temperature, color rendering or purity, light intensity, soft versus hard lights and shadows, and how to prevent glare. Dave at ThunderMesaStudio lights his layouts with track lights and LEDs. He recommends spotlights because they cast shadows the way the sun does. He uses softer lights to fill in the shadows a bit. Dave also uses blue LEDs for a simulated nighttime look. I like the blue nighttime look and adopted it for the BBL. I priced track lighting, but it was beyond my budget. Instead, I chose less expensive LED light strips, even though they don't look like sunlight. The next design problem was how to mount the LEDs above the train board. I had assumed I would have valances, like Grant Eastman's Southern Alberta rail layout. However, I found out that my apartment's walls and ceiling aren't strong enough to support heavy wood construction. So how can I avoid glare from my LEDs without a lighting valance? Eventually, I found my solution for non-glare lighting, a special type of LEDs called cob or chip-on-board LEDs. Cob strips are brighter than standard LEDs because they have more diodes, but they don't produce glare because they're covered with a phosphor coating. This coating blends the individual lights into a continuous alluring glow like neon tubes. To suspend the cob lights above the layout, I decided to build a grid of lightweight aluminum angle, which could be anchored to the walls and hung from the ceiling with fine chains. I was worried whether the 2-sided adhesive tape on the LED strips would come loose over time and cause the strips to droop down from the grid. I decided to anchor the ends of the strips with epoxy putty. More on that later. Here is a full list of parts. Download the list from a link in the video description below and refer to the list while viewing. Now, let's see how I built my light grid, starting with the LEDs. The grid has 3 10-meter long strips of white cob LEDs, one strip for the back row, another for the middle, and a third for the front. The LEDs are densely packed under the phosphor coating, 528 diodes per meter, or more than 13 diodes per inch. The LEDs require 24 volts of direct electrical current. Each meter of lights draws 14 watts of power. I chose 24-volt LEDs instead of 12-volt because their illumination is more even from end to end. I wanted a color temperature of 4,000 degrees Kelvin, which is a compromise between blue outdoor light and yellow indoor light. The color purity rating of these LEDs is 90%, which means that their light will give accurate colors in photos and videos. For nighttime, my fourth row of cob LEDs is blue. It has the same density and power rating as the white ones. If I want dimming in the future, this will work. Now, let's take a look at how I made the frame for my light grid. A metal wholesaler in my area provided this aluminum angle stock. The angle profile resists bending. I cut the stock into 30 pieces of precise lengths and angles on a radial arm saw. I followed this list, downloadable from a link in the video description below. The front row lights up the perimeter of the layout. It has 8 135-degree angles to follow the layout's dog bone shape. Mating cuts for these angles were 67.5 degrees. I used foil tape to align the aluminum pieces for riveting. I bridged each joint with a stainless steel flat corner cabinet brace, held in place with 4 pop rivets. The entire frame uses 16 braces and 100 pop rivets. The strong, lightweight assembly weighs less than 20 pounds. The frame members had to cross at these 8 points. I came up with the following solution. I chose one piece to overlap the other. I cut a slot in the bottom piece to accept the top piece. I riveted together the 2 pieces. I used a short leftover piece of aluminum stock as a brace and cut a slot to allow the brace to slide over the top piece. And finally, I riveted the brace to the top piece. This method created absolutely rigid joints and a light grid that won't flex. I built the light grid in left and right halves atop the benchwork, then lifted up the 2 halves on stilts to install on the ceiling. The 2 halves will be removable when we eventually relocate. Next, let's see how the light grid was installed. The light grid rests on the wall cleat and hangs from the ceiling. I made the wall cleat from 4 poplar boards, cut them to length, pre-painted them with latex wall paint, and anchored them to the drywall with 16 hollow wall anchors. The 13 legs are fastened in place with small hex head wood screws. The wall cleat supports half the total weight of the framework, about 10 pounds. The other half of the load is supported by the ceiling chains. Together, the wall cleat and ceiling chains hold the frame absolutely level. This light grid's not going anywhere. The 6 ceiling chains hang from these toggle bolt hooks, washers, and nuts. The load rating of all 6 hooks is 90 pounds, or 9 times stronger than their actual load. The stainless steel ball chains have these double ring clasp connectors to attach to the hooks. These screws secure the chains to the frame. The 6 chains together are rated to bear 125 pounds, which is 12.5 times greater than their actual load. The hook chain assemblies are super strong. This is the process to hang the chains. The final step was joining the left and right halves to a central leg using these machine screws, washers, and nuts. The leg is anchored to the wall cleat behind. The job of the central leg is to support the wiring harness. PEC's water tubing was repurposed as wire duct for the wiring harness. Construction adhesive holds the wiring duct in place behind the train elevator board. The wire harness is fed down through the wire duct, emerges through a hole in the train elevator board, and distributes to the power supplies below. Next, we'll discuss how the light grid is powered. The two 24-volt DC switching power supplies each can generate 360 watts of power. Each supply has 3 outputs, but only 2 of them are used. The reduced load makes the power supplies last longer. Another 2 DC power supplies with the same rating are reserved for future use when the upper deck of the train layout is installed. They'll be wired to the lower row of switches. The power supplies are plugged into a surge protective power strip. The power strip is plugged into a switched electrical outlet on the side wall and controlled by the wall switch near the train room door. I decided to hang the 4 LED power supplies from steel brackets that hold up the central span of the lower level benchwork. I fabricated custom brackets from 1/4-inch plywood and sheet metal screws. This location is out of the way and provides good ventilation and sound dampening for the power supply's ventilation fans. I ordered an ABS plastic junction box to build my switch panel. It has threaded brass inserts for the screws attaching the front panel. I used a drill press to carefully cut 8 1-inch holes for the round rocker switches. I printed a label on a laser printer, laminated it with clear plastic packing tape, and rubber cemented it to the switch panel. After soldering pairs of wires to the switches, I press fit the switches into place and brought the wires out through holes in the back of the panel. I soldered 56 spade connectors and screwed them to the terminals. The switch box is mounted here temporarily. Eventually, the switch panel will be mounted permanently on the main control panel. Next, let's see how the wiring was done. All of the light grid wiring is 20-gauge stranded hookup wire, red for positive and black for negative. The LED strips have cut marks every 45 millimeters, or 1 3/4 inches. The cut locations have exposed copper pads for soldering. I used 60/40 rosin core solder. Before soldering, I beveled the corners of the strip, then slid on a short piece of shrink tubing. Next, I applied a tiny dab of flux and tinned the pads with a touch of hot solder, being careful not to overheat the strip. I wiped off excess flux to prevent corrosion. I soldered pre-tinned wires to the pads. Then I slid the shrink tubing over both solder pads to insulate them. I tested to confirm my solder joints, then finished the job by shrinking the tubing with a heat gun. The entire light grid has 152 soldered connections. Luckily, every solder joint tested okay. Solid-state LEDs rarely fail, but just in case, each positive lead has an inline screw-type fuse holder with a 6.3 amp quick-action glass fuse. I cleaned the aluminum so that the double sticky tape of the LED strips would adhere permanently. However, I was still worried about the wires pulling the strip loose. I needed heat-resistant adhesive to secure the wiring permanently to the frame, and discovered the perfect solution, epoxy putty. Temperature-resistant epoxy putty is designed for high heat repairs, such as tailpipes, mufflers, and engine blocks. The putty comes in a resealable tube and is wrapped in plastic. I cut off pieces of putty as needed and resealed the rest. The putty has a layer of hardener wrapped around a resin core. I kneaded the putty to mix the resin and hardener until it was uniform in color. Once mixed, the putty has about an hour of working time. I roughened the aluminum to make sure the putty adhered. I pressed the putty onto the loose wires and solder joints, taking care not to get putty on the LEDs themselves. After curing for 24 hours, the epoxy putty was rock hard and stuck permanently to the aluminum. I masked around the puttied areas and sprayed with this heat-resistant silver enamel paint, which is designed for car exhaust systems. The putty and paint gives the lighting grid a finished look, as well as peace of mind that the LEDs will never come loose. Now for the light grid's final hookup. The final hookup was on ladders, so soldering the LED leads to the wiring harness was impractical. Instead, I used these lever-type wire connectors. I crimped ferrules onto the leads. Inserted the ferrules into each connector and snapped shut. Easy. The connectors grab the wires tightly. They should hold for a long time. And voila! The light grid was complete. Thanks to family and friends for all their help. The final evaluation of my light grid for the Bethany branch line must wait for the upper scenic level build. However, here is my initial evaluation after getting the light grid up and running. In terms of cost, the money I saved by using LEDs instead of track lights was offset by my heavy investment of time and labor. I'm not sure I would have chosen this design if I knew in advance how hard it would be. In terms of build quality, the light grid is a great success. Strong, lightweight, attractive, and likely to last for years. Lighting accuracy is also good, targeting the train board's back, middle, and front, plus a blue nighttime effect. But lighting realism is compromised by the lack of spotlights to emulate sunlight. The LED's flat light looks more like an overcast day. Perhaps the scenic backdrop should have an overcast sky to fit the flat light from the LEDs. Overall, I rate the lighting grid a success and look forward to years of use. With my light grid operational, the Bethany branch line in N-scale is ready to start laying track. Stay tuned for further developments. And as always, thanks for watching.